All right, it says the base of a lampshade is a regular hexagon. So they're talking about kind of this bottom part here. It's hard to draw two-dimensional objects in, or three-dimensional objects in two-dimensional space, but you give it your best shot. So like this is a hexagon. It's not great, but that's a hexagon. Six sides, right? And then the going up, there's these triangles on each face, and you see that on your image on the right on your screen, on the right side of your page. Do you see that?
How it's like the lines that make it go up to make it 3D.
But yeah, so like, yeah, like there's 6 triangles that go all the way around. And it's that lamp to the right. And it's hard for me to see, but maybe you're looking at it, so it's a little easier to visualize. Are you seeing that's what I'm referring to? Like one of these triangles is this one here. What is that number off to the right here? Is it 10? I can't see. It's 10. Okay. All right. So we need to find the surface area. So the surface area is the 6 triangles plus the area of the base. And that base, I guess you can't see, but it's underneath here. I don't know if you see that or not, but it's underneath the triangle. Okay, so the first part is to find the area of the triangle. Now that's why they give you this 10. They tell you that's 10, and they tell you the side length is 8. So this is 8 along here.
So you do 10 times 8 and divide by 2, right?
Yep.
Since it's a hexagon, it has 6 sides.
Well, actually, let me make a comment about that. Yeah, there's 6 triangles, but what there is not a piece of glass underneath here. It's just the triangles.
There's nothing underneath?
No, like I have a lamp, I'm sure you do too. The lamp shade is, I don't know, it's like open underneath. You can stick your arm under there to turn the light on or off. So the area of a triangle is 1/2 base times height, like you said, 1/2 8 times 10, which is 40. Now it's 40 inches squared because it's inches times inches. Okay, and then how many are there total? There are 6 triangles in total.
So 40 times 6, right?
Yep. So if you're seeing my screen, you'll see the final answer there to compare to.
Yeah, I see it, 240.
Okay.
So that's it. That's just the answer.
Yeah. They're just trying to give you like the equivalent of story problems. These are like application problems of surface area. All right, let's take a look at 14. So 14 starts what's called composite shapes, and composites where you have one attached to the other or subtracting from the other. Okay. So when you look at a problem like this, hopefully you see there's kind of a prism down here on the bottom, and then a pyramid on top. It's a rectangular pyramid because 5 and 4, they're not the same. So there's different types of pyramids. There's actually triangular, there's square, there's rectangular, And then you can actually go up for everything, pentagon, hexagon, so on.
So
But that's just an aside. That's just sort of extra information. You've got to find, and we either need to start with the pyramid or the prism. You've got to find the area of each face. So do you want to start with the pyramid or something else?
so if we do the square or the cube, and we find the area of that,
Yeah,
then
so let's do
know-
the front face. The front face is 5 times 4. Okay, but the back face, do you see how the back face is also the 5 times 4?
Mhm.
So I would multiply that by 2. Plus, now let's do the right side. The right side is also 5 times 4. But the right side is the same as the left side, so you can just double it. Not always, but in this problem it is. Now the surface area also includes the base. The base is what it's sitting on. So we have to add 5 times 5.
and yeah, 25.
Right. So we got 40. We've got another 40 and 25. So what is that?
105.
105 feet squared though, feet squared, because area is squared.
Okay. And then,
All right. Now we got to do the triangular parts.
so 6 times 5. So 30 times 4, 120.
Yep, 6 times 5, but you got to take a half of it for a triangle, right?
Oh yeah. So 15 times 4.
Times 4,
60.
60 feet squared.
Okay.
Okay. Now now you have to add these together and you get 165 feet squared. Now, importantly, this is very important, wherever they overlap, see how they overlap right here at the top? You don't count that for either of them. And that really comes into play on question 16.
So, oh, you're saying they don't overlap?
No,
'Cause
I'm saying it, no, this does overlap, but you don't count it. Because it overlaps, you don't count it.
okay.
It's not exposed. See how like if it were raining, you get a lot of rain in Florida. We don't in Arizona as much. Like any of these faces could be hit, right? Left, right, front, back, they could be hit. These could be hit. Now, the only thing you might say, well, Matthew, the bottom can't be hit. And I'm like, you're right, can't be hit. But for sure, this inside part here is definitely not going to be hit with water. So your surface area is anything that's kind of like exposed. Another way to think of it, and it's not a perfect analogy, but like paint, you can paint any of the exterior walls, but you don't like paint the ground. But again, it falls a little bit short because the bottom here is also a surface area part.
Oh,
Any questions on that? Because I think it might be good for us to move on to another problem.
so that is the final answer, the 165.
Yes.
I did everything right except I forgot to divide by 2 with the triangles.
Yes. So you must you must learn the formulas. They come back over and over again in math. All right, I'm gonna just step away for 30 seconds here, just grab some water. Give this a try, and I'm gonna check in with you in 30 seconds. We'll see how you're doing on this one.
All right.
All right, Craig, tell me what you've done so far in this problem.
So far, I figured out that the triangle, 3D triangle, is
Mhm.
50 feet squared because
What did you figure out for this length right here?
that is 5.
It's 5, so it's 1/2 5 times 5, right? For the first face.
Yes,
Okay, but then how many do you have?
4.
4. Now, just be careful here. It just so happens that this is also 5. It might not be in another problem, like they could make that a different length.
Oh, okay. Yeah, I didn't check that. I didn't check that part.
Yeah, and same thing for the lot. Like it hasn't in all the problems we've done. Let me scroll up. This one, they were both the same. In this, well, this first one wasn't, but that's kind of something to look for. That's a little tiny little detail that could get you on a test or a quiz. Okay, so we got what'd you say, 50 feet squared, I think, for that.
Yes. Yeah.
Okay. All right. And where do you want to go from here? What's the next
I'm doing it right now.
okay.
For the rectangle one.
So it's a rectangular prism. Let's
Rectangular.
practice. Yes.
All right, so for that I got 256 feet squared.
Okay, before I confirm that or not, tell me what you did for steps. What did you multiply?
So what I did was first 12, you see 12 feet on the bottom, times 4 on the
Okay.
side.
Okay, so you did the front face.
Yes, which is 48, and then there's 2 of those sides.
Okay.
Which is 96 together.
Good.
Then I did the top sides, which was 12 times 5.
Well, but wait a second. See how it doesn't include this. Maybe you're going to tell me that the top just includes this part.
Oh.
So that part is 7 times 5.
Oh, well, in that case, 7 times 5. Let me show you. So 35.
Okay, so one of the things you could do is you could actually label, like, this is the front and the back. This is the top. What is the bottom?
What's the
bottom
bottom?
is 12. Yeah, do you see the bottom here?
Oh, yes.
It's 12 times 5. The bottom is a rectangle. Do you follow that?
Yes.
So for some students, what I recommend is actually like laying out the shapes. I'll show you that on a different problem, but let's keep going with this. So that's 60. Now, how about the right and the left side?
Round option. 5 times.
I think it was 4.
And
there's 2.
5 times
and there's
4.
2 of them.
So, 20 plus 20.
Yep. So we just got to add this up. So 60 and 40 is 100. 96, 196, add the 5, 201, add the 30, 231 feet squared.
Now that
now you got to add the 2 numbers together. So plus the 50 from
plus 165, right?
where is the 165 coming from? I thought it was 50.
No, it was 50. I was looking at a different problem because my
previous problem.
work is messy. Yeah. So 281.
Yes, feet squared.
Mm-hmm.
Okay, let me show you something that I think could help here. We got plenty of time to look at some more problems here, but I think this will help. This is the classic tent problem. Have you ever gone camping?
Yes.
Okay, so in this problem here, this is a tent. It's actually called a triangular prism. Triangular prism. And the reason it's a triangular prism is because the triangle is what's extended. Hopefully you can visualize that, drawing a triangle and then extending it. Okay, so let's say the base is 6, the height is 10, and the length of this thing is 15. And we'll go meters because we haven't done meters yet. Although that's a pretty big tent, but it's somewhat reasonable. So how many triangles are there in this picture, in this tent?
Two.
There's 2. So what I actually like to do is I like to put the multiplier. You ever seen like a parts list? You ever like use Legos or bought something from like a store that you got to put together?
Yes.
I like indicating that there's 2 of them like this. And then I label the drawing 10 and 6. Okay. Now there's one bottom here. So I'll say times 1. What are the 2 dimensions of the bottom here? Do you see that it's 6 and 15?
Yeah.
Okay. Now, there's one of those. And then finally, there's this kind of like, I don't know, other part there, which I didn't lay out. Let's call it, I didn't pick good numbers.
15 and 10.
Well, I didn't pick numbers that work, but let me call this 12, even though that's not right. So the dimensions of this other one is 12 and 15, but there's 2 of them. Okay. So the reason I do it this way is I make sort of it's almost like a table. Okay. So there's the area of the triangle is 1/2 6 times 10, but there's 2 of them. Plus this rectangle is 6 times 15, and there's 1 of them. Plus the area of this other rectangle is 12 times 15, but there's 2 of them. It's no different than what you've been doing, but it may help you in some certain problems to make a diagram like this to illustrate the surfaces.
Okay, could I work that one out?
Absolutely.
All right, 1 second. Okay, I think I got it, at least for the
Okay,
first 2
so this is 60 meters squared. This is 90 meters squared. And then this is 360 meters squared. So you add them together and you get 510 meters squared.
Yeah. Because with the first one, 6 times 10, 60 divided by 2, make it 30, and then you have to do that twice. So it's 60.
Yep.
Second one, and then 10 times 6, 60. Excuse me, and then 5 times 6, 30, so 90.
Mm-hmm.
And then could you scroll up a little?
Sure.
Thanks. And then 12 times 15. So you do, I like to like divide it and like split it up a little.
Mm-hmm.
So I do 10 times 15 first, which is 100 and 150. Then I would do 2 times 15, which is 30.
Good.
Now I'd add 115 plus 30, which is 180.
Excellent. Yeah,
And
That's
do
great.
that twice.
Yep.
And then you have to do it.
No, that's perfect. So I think that kind of takes care of that. You said there were some more problems to do after 16? Or is that it?
No, actually, yeah, that was it.
Okay. Want to ask you, you mentioned something earlier. You said your handwriting or your organization of math problems is not very neat. Is that a true statement? Are you or were you just being very critical of your work?
In between. I'm not that
Okay.
needy, but I'm not that salty.
Now, if the instructor came to you and said, Craig, I'm going to grade you just based on how neat your work is, do you have the ability to be super neat?
Yes.
Okay. Do you like to work out problems vertically or horizontally?
Well, if I'm adding, I like doing it, or multiplying or dividing horizontal. I mean,
Like
what was the other one?
you can add horizontally, but I guess I'm talking about the general flow of the problem. Do you like to sort of move down the page or across the page or some of both? What do you like?
I have to move across the page, side to side.
Okay. Got it. Well, let's cover some things that I don't know if they're here, going to be here. We might as well just get into them. Let's talk about surface area of cylinders. Can you think of something in real life that is a cylinder?
A truck with a bunch of gas in it. Like
Yes, it actually has. They actually have hemispheres on the ends. But that's a good one. How about something maybe in the home, food or something in the pantry, glass. Although interestingly, glasses actually tend to kind of flare out.
Yeah, I guess so.
Like a wastebasket, believe it or not.
Well,
What do you eat when you're sick? At least most of us do.
what do I eat?
Yes. Soup, right? What does soup come in?
Oh yeah, a bowl.
Can. You put it in a bowl, that's right. But it comes in a can. Not every soup, right? You can get other things in cans, right? So cans are the traditional thing that you think of when you're talking about cylinders. Have you ever taken the label off of a can?
Yes.
What shape does it make when you take it off?
Like a really weird shape because like half is still sticking on and half is ripped off.
You are super literal. And it's good. It's a rectangle. If you could do it perfectly. I like it though. I like that. So believe it or not, if you could cut right down the label, take it all the way off, it becomes a rectangle. Can you believe that? Have you ever taken a piece of paper and just rolled it up into the shape of a
To make like a telescope kind of.
yeah, well, that's got a flared edges. Another one would be taking like a paper towel or toilet paper roll and cutting it and laying it flat. You'll see the shape here of a square, a rectangle, sorry. Just kind of interesting.
Yes.
So the height of the cylinder is this right here. You follow that? That makes sense to you?
Yeah.
The distance all the way around a circle, what name do we give to that?
The circumference.
You go all the circumference. What is the formula for circumference, if you know?
I forgot.
There's two options, 2 pi r. 2 pi r is my favorite. Some people use pi times diameter, but this is the sort of the more normal one.
Wait, 2 times pi and then times radius?
Yes.
Or could you just do
Times
radius
r,
times 2 times pi? Either one?
So what you just asked me is 4 times 5 times 6 the same as 6 times 4 times 5. And you tell me,
Yeah.
are they the same? Are they the same? Yes. I
Yeah.
heard a yes. Yes. So the order doesn't matter. Traditionally, this is how it's presented. And I think that's important to you. So I want to present it to you the sort of the math correct way for you to look at. Okay. Now, what is the top of the can? Like if you were to get a can opener out, what do you get when you cut off the top of the can? What shape?
A circle.
Circle. Now, how many circles are there? Because you've also got one at the bottom, right?
Yeah, so 2.
2 total. What is the area of a circle? Do you remember that?
Yeah. Radius squared.
Pi r,
Times.
yep, pi r squared. So notice the surface area of a cylinder is this rectangle, which is 2 pi RH, plus the area of the circle, which is pi r squared, but there are 2 of them. So this is your formula for the surface area of a cylinder.
So 2 pi r times height. The 2 is because there's 2 of them.
That's right.
That makes sense.
So let me give you a problem here. So let me give you a can.
One moment.
Sure.
Sorry about that.
No problem. So I've got a can of Planters mixed nuts here on my desk, and I just measured it. And
Yep.
height of this cylinder, this can cylinder, is 3 inches. The diameter, not the radius, the diameter is 4 inches. And I want you to find the surface area of this.
You want me to, is the surface area like the formula you just had in the rectangle,
Yes,
like everything?
It's a cylinder. Yep.
Okay, so I'm gonna use a calculator for this because that's pi.
Oh, no. We're not gonna use a calculator for this. Let me do one with you.
But
What?
so 3.14 or
Nope,
just
we don't need to use that. Then I'll talk about why in a moment. What is the radius of this?
2.
It is 2. Okay, so radius is 2. What is the height?
3 inches.
What is the radius?
2.
Squared. Okay, now we just talked about this. You get to choose the order you multiply these in. So you can do 2 times 2 times 3, then times pi. What is 2 times 2 times 3?
4 and then 12.
So this is 12 pi. Plus, what is 2 squared?
4.
Okay, times the next 2.
Wait, when something is squared, it's just multiplied by itself, correct?
That's correct, yeah. But then you got another one here to deal with.
So you do it to whatever the answer it is for what you just squared. You do that and then add itself.
Yes. So it's 2 times 2. That's this part over here times this other 2 is 8 pi. These are considered like terms, so you can add them together.
Because like they both have the pi next to it.
That's right. That's right.
Like a like term is like 8x and 3x.
That's
but
right.
not a like term is 8x and yx.
I agree.
Right?
Yeah, that's a good way of describing it. It is correct. What are the units of area in this particular problem?
Well, for area, it has to be pi times
No.
radius squared.
No,
So
units, Craig. What
oh, it's
units are we dealing with?
inches.
Inches squared. Okay, so this is what's called an exact answer. And this is what we want to move you towards. This is what you'll see on standardized testing.
Okay.
We have just a few minutes left. In the last couple of lessons, I noticed you wanted to ask a question at the end. Is there something else you would like me to answer? Something you want to quickly get answered here at the end?
So I'll just go ahead and ask this. So could you just do make another cylinder problem just so I can try and do that?
Sure. I'll make it here, but you can either get it down or we can put it with the notes at the end. Yeah, so we'll give you the diameter is 10 centimeters and the height is we'll go 14 centimeters. Is your dad around?
Yeah, I can get him.
Do you? I don't know. Yeah, why don't you grab him real quick and we'll just spend a couple minutes chatting.
Okay. I did.
Yeah.
All right, so I got my dad.
Hey,
Hey Rick, we were able to get through his homework assignment and work on a few other problems. I don't know if you want to check in at the end of each lesson. I mean, I'm happy to do that. But do you have any questions or anything you would like to discuss? We've got a few minutes here left on the lesson.
no, just how do you think he's coming along? And if as long as he's coming at your pace, and that's all we want to see. And then I think Craig, did you tell him about your latest scores? I mean, at school he's doing fantastic.
Yeah, he
So
did. He did, and he's great. He's great to work with. I wish every student was like Craig.
Oh well, thank you. God,
I mean, he asks good questions. He wants more problems. He wants to work them out on his own. I really enjoy that. Plus, we're able to kind of, talk about he'll maybe tell you later. I'm trying to give him where does this apply in life? Like, where do you see cans or cylinders? And we talked about cans, and there's just a lot of applications to real life, specifically in geometry, because it's very visual. So
I'm so glad you're doing that, because even though he's doing well, he kind of gets that, when are we going to use this, or what? I'm going, and then so for you to really put it into real life, like, hey, you're going to need, anytime you see a can of Coca-Cola or a can of soup or this, or what's half of that, what's the label? I kind of was hearing the label thing and saying, that's actually a rectangle that goes halfway around it, and et cetera, et cetera. I'm like, that's cool stuff to know. And he's into, he's into all of that, but he's also into marketing and design, and to think, oh, well, that's what a label needs to be, a rectangle, but then it goes halfway around the can, and et cetera, so that's kind of cool. But yeah, I think what I was excited about is that he is up to that. You guys are all on the same page of where he is. I remember the first session, it was like, well, where are you in your school and what are you doing? So I know you guys now are on that. You've seen some of his work and some of his tests and wherever they're at on that. And then I guess it's just a matter of getting ahead of that game. And then I just spoke to there's like a digital thing for the ISEE, and it has some practice tests and stuff like that. And the lady's like, well, gosh, most people only do that with like 2 or 3 months before they take the test. And I was like, well, I don't think of it that way. You know,
Yeah,
I
no, that's good.
but yeah, I said, think about this. I said, and I don't know if this woman was, a mother or not. I said, you're coming back from summer vacation. It's the beginning of his 8th grade year. You're supposed to take the test in late October, early November. So you have September with new school, new teachers, possibly sports, commuting, and you're going to throw in a new test to study all within a month and a half. I think that'd be a little bit of a jam. And she's like, oh, you kind of bring up a good point. I go, but yeah, most of these kids only buy it with. I said, no, I want to get this in advance and to be able to pepper, work on it. Maybe it's 20 minutes a day. Maybe it's 20 minutes every other day. But so that's the next thing I'm looking at. Yeah. So they said, oh, well, we only licensed this for 12 months. I said, all right, let's talk to your supervisor here. I know what it takes to extend that digital license.
Absolutely.
Just a switch.
Yeah.
So they said they'd call me back. So if that's the case, then we'll start working on, if he's ready, the lowest and the easiest parts of the SSAT and the ISEE.
Absolutely.
And,
Yeah.
Then
We'll do
that
that.
way it will be so when that day comes, so we're about a year ahead of schedule, but when that day comes, as you know, then it will be the confidence and the speed. I know you were talking about that. I overheard the last session as saying, okay, well, what if you only have 4 minutes for this question? What if you only have this amount of time? So that's where practice makes perfect, and knowing it and thinking about the cylinder,
Yeah.
thinking about the rectangle, and thinking about, all that.
Absolutely. Hey, Rick, I do got to run here. I got another thing to get to. We can always
Great.
talk another time, but I'll see you guys next week. Good working
No,
with
man,
you,
we're more
Craig,
than
and I'll
thrilled
send
with
you the
having
notes
you
here
as a
shortly.
tutor. We love it.
Absolutely. All right. See you guys. Gonna run.
Matthew.
Bye.
You're welcome. Bye now.